Hey everybody, Mr. Buckle back with problems 11, 12, 14, and 15 from your Algebra Chapter 8 practice test. Up on the screen here we have the expression 4g to the fourth, h to the fourth, to the third power, and we are asked to simplify that expression. So what we're going to do is use the power of powers property primarily here. We have 4 to the third power. We are going to do g to the fourth to the third power, and then we're going to do h to the fourth to the third power. When we do this, we get 4 to the third power is 4 to the third power. G to the fourth to the third power is g to the 12th, because I multiply these two exponents together. And then h to the 12th comes from h to the fourth to the third power. Power to a power, we multiply the exponents. The only simplification I can do from here is 4 to the third, and 4 to the third is 64. And I leave the g to the 12th and the h to the 12th alone. I can't combine those things. I can't multiply them because the bases are different. So we leave the expression as 64 g to the 12th times h to the 12th. Problem number 12, similar type of problem, but we have a fraction, and in the numerator we have 2a to the 5th times b, that quantity squared, over 24b to the 6th. So the only thing that's being squared here is what's inside the parentheses. So we're just going to square the 2, the a to the 5th, and the b. So we're going to do 2 squared, a to the 5th squared, and b squared. When we do that, we get 2 squared. A to the 10th comes from a to the 5th squared, and b squared comes from b squared. And notice the denominator stays the same because the denominator is not being squared. It's just the numerator that's in the parentheses there. So we have a little bit of simplification we can do here. We can do 2 squared. 2 squared is 4. And then we have a to the 10th b squared, and in the denominator we have 24b to the 6th. So to get from here down to here, all I did was square the 2. But there's a little bit more simplification we can do because we have the same bases in the numerator and the denominator. We have b squared in the numerator, b to the 6th in the denominator. We can use the quotient of powers property there and subtract these two exponents, giving us b to the negative 4th. But that's like just having b to the 4th in the denominator, because there are 4 more b's in the denominator than there are in the numerator. There's 2 in the numerator, 6 in the denominator, so these 2 cancel out with 2 in the denominator, leaving us with 4 in the denominator. And then you'll notice the 4 and the 24 are also gone when we go from here down to here, because 4 over 24 can be reduced to 1 over 6, or 1/6. 4 over 24 is 1/6. And now that we have that, no more simplification can be done, and we're stuck with a to the 10th over 6b to the 4th. Problem 14, we're going to simplify the expression and write without negative exponents. So the first thing I want to do here is eliminate all negative exponents. Let's eliminate the negative exponents, so I need to identify the negative exponents in the expression. And I see a negative exponent on the m, because we have n to the negative 4th. I see a negative exponent on this n, because we have n to the negative 2nd. And I see a negative exponent on this p, because we have p to the negative 4th. So to get rid of those negative exponents, what you're going to do is move those bases with the exponents to the opposite numerator or denominator, depending upon where they are. So when I do that, I get this. So we'll notice in the original expression we had 36, which is still there, because it does not have a negative exponent. M to the negative 4th. Notice that's not in the numerator anymore. It's in the denominator. It's right here. And notice that the 4 is not negative, because when you move that to the denominator, the exponent becomes positive. The n to the 6th is still in the numerator, because the 6 was already positive. We don't have to move that around because it's already positive. In the denominator, the 4 is still in the denominator, because there's no negative exponent. This m right here is still in the denominator, because that did not have a negative exponent. It has an exponent of 1, because there's no exponent there. Notice this n to the negative 2nd is gone. It's not in the denominator anymore. It's in the numerator, and the 2 is positive, because when I move it from the denominator to the numerator, it becomes positive. And similarly, the p to the negative 4th, that's no longer in the denominator. That's in the numerator. And notice the 4 has become positive. So all our negative exponents are gone. We did that by moving them from numerator to denominator, or vice versa, and making them positive. Now we want to simplify because there is some simplification we can do. I can do n squared times n to the 6th. If I multiply these two things together, then I add their exponents. Same thing with the m's. There's no exponent on this m right here, so there's really an exponent of 1, so I can add these two exponents here. So when I do that, I get n to the 8th. N to the 8th comes from n squared times n to the 6th. 2 plus 6 is 8. The p to the 4th stays as is because there's no terms to combine that with or no similar bases. And in the denominator we have m to the 5th because m to the 1st times m to the 4th is m to the 5th. And then you'll notice that the 36 over 4 is now gone, and now there's a 9 there. Why? Because 36 over 4 is the same as 9, or 9 over 1. And this is our simplified expression. And our last problem here, we're going to simplify 2a over a squared to the negative 2nd power. So the first thing I'm going to do is get rid of that negative exponent. I don't want that negative 2 there. I don't know what anything to any negative exponent is, so I have to manipulate it and make that exponent positive. To do that, I'm going to use the negative exponent property for fractions by taking the reciprocal of the fraction, and then the exponent becomes positive. Notice this negative 2 is now a positive 2, and I flipped the fraction. It's now a squared over 2a instead of 2a over a squared. So now I have a squared squared over 2a squared. So when I do that, I get a to the 4th because a squared squared is a to the 4th. 2 times 2 is 4. 2 squared is this 4 right here. And a squared is a squared. A little bit more simplification we can do because we have a's in the numerator and in the denominator. The rule for that is we subtract their exponents if we're dividing them. So we get a squared over 4. And the reason the a squared is in the numerator because there were 2 more a's in the numerator than there are in the denominator. So these 2 a's cancel out with 2 of the a's that are in the numerator, leaving us with a squared over 4. And we are done.